So as James mentioned, I work at EDINA, which is part of the university but does stuff for the whole UK higher and further education sector. I've been involved in a few crowdsourcing projects, so James asked me to talk about what it's like to actually set up one of these projects, what's involved. So my slides are a bit wordy, apologies for that. But I wanted to kind of flag up how many different things you have to consider when you get started. So the first thing, I think, is this issue of, is this actually about doing the science or is it about communicating the science? Because how you build your project, what technical tools you use, what kind of quality is required is going to vary greatly depending on what the output's going to be. If it's going to be educated, empowered citizens, or if it's going to be a bank of scientific data, or if it's going to be both, because it might be both. My personal background is in things like social media and communications, so I'm particularly interested in how people identify their audience, how they identify the community they want to get involved. I know on James' slides he sort of said, how do you create a community? This is one of the difficult things. You don't generally create a community. A community creates itself, or you tap into a community that's already there. So that's quite an important part of setting up these types of projects. Galaxy Zoo was tapping into a really well-established volunteer community that was already used to working as volunteer participants with the professional community. So they had a ready kind of audience to go to there, for instance. Identifying what kind of engagement you require or prefer, because some projects require you to just sit there and identify an image or do something quite passive and quite small and doesn't require you to become sort of trained or expert in the knowledge. Some crowdsourcing projects expect you to know what you're doing to start with, expect you to engage and be trained up in some way. There's a grave site tracking project in Ireland where they train you how to take the right kind of photograph and how to transcribe the gravestone in the right way before you can go and take part. So there'll be different barriers to entry and different levels of engagement that's expected. There are technical considerations. I'll talk a bit more about that because that's kind of my hat, really. But about what's necessary, what's possible, what citizens can actually access and use, and that latter one is going to shape who can take part. And I think when you understand the data that's being contributed, understanding which citizens have been able to take part and which ones have been sort of focused on can make a big difference to the kind of data they've submitted. Quality has already been mentioned. I'll come back to that. What kind of support and engagement you're going to provide, what kind of scaffolding you're going to provide. There's lots of kind of science education elements, even if that's not your main aim, to get that quality of data out at the end. How are you going to design communication, feedback, things that reward people for taking part? No one is going to volunteer if they do not feel motivated or rewarded for taking part in some way. Now that might be financial, that's possible. Most projects I've been involved with, that's much more about participating. And in my case, it's about environmental science, so it's about contributing to the well-being of the environment about them in particular. And there's sort of mechanisms to actually exit things, which is something that does become important if you've got a limited funding on your project, which most of the ones I'm involved with tend to have, so that's kind of an important consideration at the start as well. If people are giving you all of this time and effort and you're raising their expectations, what's going to happen at the end to their data, to them as a community? What's the outcome for them? So I mentioned the sort of issue about purpose, whether it's science or science communication, and I think that James already touched on this anyway, but it is worth saying, does the science matter? And if it doesn't, how are you going to motivate your volunteers? Because if you're there to sort of educate them, are they going to go for that as a purpose, or do you need like a bigger purpose to get them involved? Does it matter who volunteers? It might not do. If it's a very mechanical sort of task, anyone might be able to contribute equally. But perhaps you're trying to reach out to a particular audience or trying to empower a particular group of citizens. And in that case, how are you going to make sure that it works for that particular group? And if you are going to empower them, how do you make sure that actually is the case? A lot of the projects that attract a lot of volunteer participants, the volunteers are not the people who lack empowerment in everyday life. They're the people who are, particularly well-educated, particularly connected to things. If you're going to reach out to an audience beyond that, that takes a certain kind of novel approach requirement. You have to think quite carefully about how that's possible to do. James mentioned the idea of how do you break this into little tasks. A different side of that is also how do you kind of design those tasks to make sense to someone who's filling them in. So there are lots of things you can break into small tasks, but how you make that make sense to your community is also important. One thing I wanted to mention very briefly was gamification. So there's lots of debate about gamification in the sort of citizen science and crowdsourcing world. And in terms of how you can trust the data you get back out of people, there are some negatives to gamification. It can be an approach that potentially rewards the wrong type of participation. So lots of volume of participation, lots of activity. It can be really demotivating for other people. That can be a reason not to do gamification, but it can also get you lots of results very quickly, which might be a brilliant reason to go ahead and do it. And different projects take different approaches on that. Quality I'm going to come back to in a second. And what kind of role will experts or more experienced volunteers play? So Zooniverse has already been mentioned. They have volunteer moderators in the community. So they give some additional sort of rights and responsibilities back to parts of that community and have created a sort of quite subtle set of different levels in that community. But if you're expecting someone to have reliable quality data and have someone to go to for expertise, is that going to always be the central team organising it, or is that going to be other people involved in the project? As someone who has tried to set up one of these projects on quite a grand scale, I would recommend it never being the team that set it up being the only source of support, because that way madness lies with many, many participants. So technology-wise, what you choose also has quite an impact on what you do with the data at the other end. So, for instance, on accuracy, what kind of technology you choose might change what the geographical accuracy of a bit of data is. If someone's collecting something out on their mobile phone, them saying where the location is may be very different in accuracy to their GPS telling you where they are, which might be different again from using their IP range to tell you where they are. There are different ways you can do it, and they have different accuracy levels. How you design the interface and how usable it is, that's going to impact on how useful the data at the other end is as well. If the task is really clear and really understandable, then it's much more likely that it'll be done correctly, fairly obviously. If the interface is sort of quite tricky or is using the wrong type of language, that can be a blocker to people taking part in an informed sort of way. So for the project I've been involved with most recently, trying to not use technical or scientific language so that everyone is able to participate in an audience of non-expert volunteers, that's really difficult to do, actually, especially if you're asking them for sort of relatively complicated sort of data to pick up. So getting that language right is really important. I've also mentioned here what kind of device you expect people to take part on will shape who can take part. So if you're expecting them to have a home computer with an internet connection, there are a lot of people that will not include. And it will include, the people who will not be included will include a very specific sort of set of people. So people who are least likely to be connected to the internet in Scotland and the UK at least will tend to be those on lower incomes, they'll tend to be older people, they'll tend to be people with disabilities, people in very remote locations where the internet's maybe not up to the kind of level you need it to be to take part in these projects. So if you're expecting them to have that kind of access to technology, you may be excluding those communities. And if that's who you want to reach, and I speak as someone working on a remotely geographically located project trying to reach some of those communities, that's a challenge to deal with. If you expect them to have mobile devices, whether you pick that your application or your interface is going to work on one handset versus another will also shape who can take part. And the fact that you expect them to have a smartphone will shape who can take part. So when you look at the kind of results of this kind of work, or you look at the community around a crowdsourcing or citizen science project, you have to understand where all of those kind of barriers to taking part were in the first place, and to what extent that shaped who's chosen to take part. And the app and data upload size may also be an issue. Maybe asking your volunteers to pay money to take part in your project, not just volunteer their time, but also their data. So that can also change who's willing to take part and what they're willing to do for you. So I'm going to give you a quick example of something that we've done at Adena. We've done an app called Field Trip, and the idea of this is it's a generic mobile phone app that lets you do data collection. It's designed to be usable, but it's not designed to be used by people who don't know what they're doing at all. One of the main reasons we built it, though, was to get something that works when there is no internet connection. It is designed to sort of cache things and then upload them when you have an internet connection again. And that's an example of us trying to kind of get over some of the technological barriers of doing geographical field work and stuff that's in more remote locations. So that is a tool that is available to researchers to use, but also an example of the ways in which you can use the technology to shape and also to overcome some of those things. James already mentioned quality, and I guess I was thinking of quality in a more sort of technical sense, perhaps. Trust in citizen science by scientists and researchers themselves is quite mixed, and policymakers also quite mixed. They're not necessarily that keen to have their scientific work done by volunteers, and that's not terribly surprising because it sort of threatens the idea of how much expertise you need to participate in science. So there's lots of reasons why they might be a bit nervous about it anyway, quite aside from not being sure if they trust, you know, their mum or their neighbour or their postman to collect their data for them. There are different kind of ways you can deal with quality assurance. Some of those are very manual. I know that Concrete Science did this to check that none of the photos they'd had uploaded was anything terribly dodgy. They had a couple of terribly dodgy photos, so it was good that they did. But other tools do it in a different kind of way. So Galaxy Zoo do it by sending out the same data to lots of different people and sort of taking the sort of modal version of that, the sort of most likely answer. You can also use kind of things like sensors. So we just heard about the fridge project. You can use sensors for weather or for sort of temperature, or things that you might be asking people to measure in a sort of more manual way themselves, and use that to check some of the data in places where you have both the people in the crowd and you have your sensors, and then you can get an idea of how much you can trust that over the kind of wider group. And you can also sort of set up some different trust and expertise levels. This is something we've been experimenting with in the project we've been working on, so that you have an idea that some results will be much more trustworthy because they're coming from project team members or trained participants, and some are at a different quality level, and you just know which quality level it's at. And that's how you use the data. You use it with a knowledge of what the quality level is. And I think something that's really important, you also have this social challenge that if you are doing kind of quality assurance, which you have to do with these projects, there is always some noise in the data, intentional or otherwise. You have to deal with the idea that people will have to have some of their data rejected. You need your participants to understand that that's okay and not feel like their time and their effort has been devalued. And if there's one thing I would share from my experience on these kind of projects, it's that making people's time count for something, making sure their contribution is valued, makes a big difference to having them be remotely motivated or engaged or willing to tell their friends or willing to actually feel good about that engagement. So the project I've been mentioning, the most recent one I've been involved with, is a European project called COBWEB, which is looking at environmental data. It's actually, again, a relatively generic approach, so we can use it for different kinds of experiments. And one of the ways in which we've been trying to deal with some of the kind of quality assurance measures is to use a kind of a quality measure for each bit of data that comes in, so that you can get a sense of, this is a very reliable record, we think this is very trustworthy, using a mixture of kind of technical and previous contribution kind of rankings. And then you can use that to work out how trustworthy you think that data is. And that's really important because we're working with policymakers and they're used to having paid expert people gather their data, but they don't have the money to have paid experts in every location they would want to gather data about. So having some idea of how much they can trust a particularly worrying reading, perhaps a particularly interesting one, and then use that as a way of doing targeted use of their sort of paid resource is really important. This has also been about sort of communication outreach, which I think is sort of the close to last slide, because I realise we're probably significantly overrunning. Communication expectation management is also really central to projects that do well with crowdsourcing citizen science. That's about understanding the level of participation, about understanding who's taking part, and how that looks. So are there going to be public events? Are there going to be ways we'll find out about the project? A lot of the environmental projects, they get a good boost because of Springwatch, which is currently on. You'll see about 10 crowdsourcing projects getting bumped out in the next week or two that's left of that. How are you going to enable that participation? Are there training levels, which there are in Zooniverse? Is there guidance within the application, which there is in Concrete Science? Are you going to put risks and warning messages up if you're doing anything with public safety? And one of our apps is a flooding app, so definitely public safety issues. You need to have kind of risks and warnings thought about as well. What's the kind of training and teaching materials around this? If you want it to be adopted by kids in school, and you can see there is a kid on a school trip playing with the COBWEB app right there. When we were doing some usability testing, I would recommend a sort of 10, 11-year-olds as amazing usability testers for software. They will break everything. What do you need to make that possible? So we had teaching materials created specially to be able to do usability testing. We didn't just give them the app. We created teaching materials to work with the schools so they could go and have a little look through. But adult participants need that kind of scaffolding as well. And again, how those are written and how they're created makes a big difference to what it is they produce, what it is they contribute. Motivation I mentioned already. It's the main thing, I think. Motivation is super important. I think also the idea of what the contingency plan is if not enough people take part, or if the data doesn't actually prove to do something exciting. It's brilliant when new stuff gets discovered on Galaxy Zoo. It's brilliant when new trends get discovered in various different crowdsourcing projects. The RSPB is quite experienced at doing this sort of, we've discovered something's extinct, sort of managing for quite negative outcomes of crowdsourcing projects. But you know, if you've got not many people taking part, you may not have any outcome at all, and that's really not very motivating for potential volunteers or for past volunteers. So thinking about how you manage expectations around that and how you're going to deal with that situation is quite important. And how you communicate the final results and the research is more complicated than it first appears. So if you're doing research on rare species, for instance, and you're happy for the crowd to alert you to where these are, and you want to share with them the results, but you don't want to expose those rare species to, you know, egg collectors or people who are going to go and try and grab and sell off these things, then how you're going to communicate that requires a little bit of careful thought, but you still need to keep your audience engaged in feeling like what they've contributed has been worthwhile. And as I mentioned, an endpoint or exit plan is sometimes quite important if you want people to invest in the long term. One of the problems is it takes a long time to get these projects going, and by the time they've got momentum, you're often near the end of your funding window. And so knowing what happens after that and who's going to take it on and how the community are enabled to take stuff on is really important. So my very final slide is some of the issues that I think some of this stuff raises, and I think that James already touched on these anyway. But these kind of projects, they really touch on the role of the citizen and the expectations of what it is to be a good citizen. COBWEB is funded by the European Union. Empowerment of citizens is very important to those kind of projects and how they're shaped and how people are trained to be part of them. The relationship between amateurs and experts, the role of reward and remuneration for work that's undertaken. And in the case of all the projects I've been involved with, there's no direct remuneration. Oh, having one of those days. But that said, some of the people who've taken part, they got access to devices as a result of being part of test groups. So they get to use the devices of the organisations. There's some remuneration in there, even though it's not necessarily directly kind of paying cash. Volunteer motivation, engagement, buy-in, really important to understand for understanding what happens in these projects. Transparency of scientific process is clearly part of what these projects are about, but how transparent the science is varies wildly from project to project. And the quality and credibility of the scientific process also is kind of a really interesting, messy area raised by these things, I think. There's also these elements of peer and community education and sort of community dynamics and roles, and I think, again, understanding those tells you a lot about what it is that you get out of them. So that's my wee, more practical, I think, end of the spectrum. Done.